To many people, it's a mystery how most electronic displays work. For example, this one here, your monitors and your TVs, how exactly they work. For this one, for example, the image is written line by line, and I think for most displays it should be the same. A line of the picture is written, then another line, then another line, like that. But it's done so fast that you do not actually see the lines being written, and it all looks like one clear image. I'm going to use LEDs here to show you how exactly it works. Using a microcontroller, I program the microcontroller using an ICD1, and then it will change whatever I want it to change, or display whatever I want it to display. At the moment here, I'm using the example of writing letter A. It's written line by line, one line at a time. Right now the refresh rate is about, I think, 3 seconds here. So every 3 seconds the image is written. One image written in 3 seconds. It takes 3 seconds wait rate, one complete image. So if we make this fast enough, due to a phenomenon called persistence of vision, we shall see this as one image. All these lights will seem to be on, and then you will see letter A. That's actually what is there. So I'm going to program and make this thing display much faster to increase the refresh rate to about one image per second. That's much faster. Every second it will display. So here I'm using MPLAB and MCC18. What is the compiler? So I connect this here. Let me increase the refresh rate by reducing the delays I have created there to increase the refresh rate something much faster. Good. And let's reprogram the controller there. Yeah, reprogram the controller. Yep, come on, we're good to go. So now at a faster refresh rate, now it has a much faster refresh rate. This is about 1 second. You can see, well, the letter is trying to form, but the speed is not yet fast enough to deceive the eye, cause that persistence of vision. So we can make it much faster. Let's make it much faster and see what happens. Right now it's about 1 second. Let's make it faster, so many times per second. Good. There. So at a much higher refresh rate. There. Now this is, I don't know how many times per second, haven't yet. I can use the counter there, the stopwatch, to determine, but you can see it's still doing the same thing, writing one line at a time, but it's doing it at a much faster rate. So you can actually see letter A there trying to form. Let me just drop the light a little bit. There, so you can see A there trying to form, but there's that flicker there, so we only have to make it much faster. I think now you also understand the concept of flicker. It's not doing it fast enough, so the eye is actually observing the flicker. So if we make it much faster, then that will die as well. We should not be able to see that, and that's exactly what we want. So let me make that happen. Yeah. I think right now it should be in microseconds, the refresh rate. Yeah, they should actually put it at less than a millisecond. So it's going to display it 1,000,000 times per second, something like that. Okay, so now there you go. Much higher refresh rate. So you can see, you can hardly see the flicker, if at all. You could make it much faster. So there is your letter A, written line by line, narrated so fast that you don't even see what's actually happening. So most of your displays, that's exactly the same way it works. Touch me. So thank you for listening. I hope I helped you.